Okay, what is up? I came home and just soldered on quick connections real quick. Made myself a little plug, a little resistor divider network using a thermal sensor going to one of the analog inputs, reading the value I just added there as I spoke of. Temperature probe I'm using is in the water right next to this one. So I'm just trying to plot the temperature on 40 degrees equals about 204. I'm just going to plot actual temperature to the value, the analog digital value, which is just 0 to 255, 0 being 0 volts, 5 being 5 volts. Just going to plot enough to cover the range that I'll be using it at, and I'll have to be able to create a lookup table that will make the temperatures accurate. And then I'll be able to, I'll be able to recalculate this. This will be actual temperature. Then I'll be able to program the temperature as I was speaking about in the last video. Okay, good news. As I plotted this down within the range that I want to read, I've got a consistent difference between the actual temperature and the value that it was reading. So I'll just subtracted 66 in one operator there. See, it says 118 degrees, and that says 118 degrees. With both probes touching each other in the same water that I heated up in the microwave that I'm letting cool off at a steady rate. 117, hopefully that'll drop in a second. If it's plus or minus a degree or so within that 10-15 degree range, I'm going to run this, who cares? All I care about is just being approximate and just setting two set points. One normal set point, which will be the typical temperature the water heater is going to cycle off via this controller. And then they're just going to have like a temperature override button for when we want a little hotter water for a hot bath or something. Push the button and it'll go to an offset temperature, a higher temperature for like half an hour or something. As long as I kind of got close enough temperature readings for this to do that accurately, that's all that matters. It doesn't, if it's plus or minus a degree or so within that scale, that's great. And that's at 116, so that's fine. Got the in-circuit programmer hooked up. All they do is hook that header pin over to here, and then I program that chip on the fly. Just hit program and it goes, and then the board resets and starts running again. Obviously I haven't set the time since I reset the power or reprogrammed it, but do that easy enough. Okay, I've made some decent headway tonight. I'm going to call it quits. Let me show you what I have done so far. As you see, I got the temperature probe. I just put a socket on there, plugging this in. So it reads temperature with this probe, which will be added to the water heater. And add a few more connections. Got the wire connected that's going to be the output for the contactor. Added an LED that shows when the contactor should be on, just idiot light pretty much. And this is just a programmer, which unplugged it. I'm done with it. Let's see that. One-handed or not. Programmer interface from the computer to that. So that's the whole control board. It's going to easily fit in a control box. Everything's pretty much connected except for just the buttons, which will be on the front panel with the LCD. I should actually just buy one of those LCDs with the buttons on it. Oh well. So I'm going to power this up. 24 volts. Chattered the relay once, I guess, as it did its initial boot up. Got the heartbeat going on. Okay, so time, which started out at all zeros. It started out Monday. I did that on purpose. And then the temperature. Once it gets down out of the useful range, the accuracy is going away, so it's not quite that cold. That cup of water is probably more closer to 70. But water heater off. I've got quite a bit added to the menu tonight. To hit my mode button. Oops, I hit it too many times there. Get back out of that. Okay, hit it once. Go to set my time. I don't want to do that yet. Minute, day, set the time on, which is by default 19 for on and 7 a.m. for off. Set the low temp. That's my settings there for my 2 set points. See, I could go up and down, and I got just a range there, and then a high temperature. That'll be the higher temperature, so I'll be able to program in 2 temperature settings, go up and down on that. And then I added this manual operator, so I could just manually turn on the water heater. There it's on. Second LED is on. It's staying steady. I don't know why, but the frame rate of the camera is making it seem like it's flashing. That's weird. But that's not flashing. Contactor is on steady. And it says on, and I could just click it off too. So I go on, off, just by, you know, just simulating touching my buttons that'll be on the front. So I'll go back out of there. So, okay, so let's go set the time to right before the scheduled on, to see how that works. I'm going to go down to 1800 hours, which would be 6 set the minute. Go ahead and get out of there. Okay. 6:59 is pretty much what that's saying. And at 7 p.m. is when it's okay for the water heater to come on, because that's when we're not on peak. There it goes. Relay's on. Kind of weird how you get the right angle. It looks, you can see the thing. Kind of, that's weird. Anyway, contactor's on, relay's on. Everything will be fine. Go over and set hour. Let's go back to 6:59 a.m. Now once that gets to 7 a.m., that contactor will turn off, which is like what it'll do normally during the day when nobody's home. The whole point is to have it turn off the water heater from 7 a.m. till 7 p.m. pretty much while we're gone, and also to keep it off during that high on-peak rate that APS charges us, 24 cents a kilowatt hour. And then this unlike my other stock timer, is going to turn it on all day on Saturday and Sunday. Here we go. It should turn the contactor off. There it goes. Contactor's off. That other LED's off. It's all working. I just have to add a little bit of code to manage the 2 set points based on the thermostat. I'm not going to do that tonight because it's like 8:30. So I'm done for the night. It's working great. So, to be continued once again.